There are 4 orbitals involved in sp3 hybridization. They are 1s orbital and 3p orbitals. The best example to explain sp3 hybridization is methane. Methane has carbon as its central atom. Carbon atomic number is 6, so it has electronic configuration as 1s2, 2s2 and 2p2. If you look at the ground state electronic configuration of carbon, we clearly have 2 electrons in 1s orbital, 2 electrons in 2s orbital, and we have 2 unpaired electrons in 2p orbital, and the electrons are located at clearly 2px and 2py. The electrons present in the outermost shell of an atom is called valence electrons. Here the valence electrons are present in 2s orbital and 2p orbital. Totally we have 4 electrons in valence electrons. The electrons present in the valence shell gets excited when the atom absorbs energy from outside source or when the atom tends to form new bonds. The ground state electronic configuration clearly states that there are only 2 unpaired electrons present in it. That means carbon can form only 2 bonds, which is clearly a wrong one to understand. Carbon does not form 2 bonds. Carbon is a tetravalent bond. Carbon forms 4 bonds around it. So the excited state electronic configuration clearly explains these 4 bonds. The electron present in 2s orbital will be shifted towards 2pz by making 4 unpaired electrons in electronic configuration. These 4 unpaired electrons mix together to form hybrid orbitals. Now let's understand the shapes of hybrid orbitals here. After the excitation of the electrons in carbon atom, the 4 unpaired electrons are present in 2s orbital, 2px orbital, 2py and 2pz orbital. The shape of 2s orbital is spherical, which consists of 1 unpaired electron. 2px, 2py, 2pz orbitals, each of them have 1 unpaired electrons, and 2px is along the x-axis and 2py is along the y-axis and 2pz is along the z-axis. We know that the shape of p orbital is dumbbell. Now these 4 orbitals, they mix together to form hybridization. Hybridization is a phenomenon where all orbitals in a set of hybrid orbitals are equivalent in shape and energy. It is a simple thing to remember that 4 atomic orbitals mix together to form 4 hybrid orbitals. We can say total number of atomic orbitals in the mix will always be equal to total number of hybrid orbitals. If you look at the shape of this individual lobe of an hybrid orbital, one lobe is bigger than the other one. The bigger lobe represents that there is a presence of unpaired electron in it, and the smaller lobe represents it's an empty place. Each of these 4 lobes have unpaired electrons and they are attached with 1 hydrogen atom to each of these lobes. Therefore they form tetrahedral shape, and the molecule formed here is methane.